So looking at some examples now, prereq section 4 is what we're looking at. Prereq section 4, rational exponents and radical examples. Ooh, a breakfast burrito, one of the best things ever created. Looking at this example, all you're going to do is take the exponents and multiply them just like you're used to. So 3/5 and 1/6 when you multiply them, just multiply across, so you get 3 over 30. We can simplify that to 1/10, so it's x to the 1/10, which if you wanted to remember, whatever is in the denominator, that is your root, so it's the 10th root of x. So negative exponents. We know we can't have negative exponents, so since that's on top, I have to move that to the bottom, so I get 1 over x to the 7/2. And because this is improper, I need to split it up, so let's split it up. To split it up, another easy way to do this in one step is change the improper fraction to a mixed number. So 2 divided by 7, it goes in 3 times, so 2 times 3 is 6. We subtract to get a remainder of a half. So what that means is on the bottom we end up with 1 over x to the 3, because there's the 3, x to the 3, and x to the 1/2. So this tells me how many whole x's I have, and this tells me how many fractions I have. So I need to get rid of that fraction still, that half. So how can I get rid of that half? Okay, a half plus what gives you a whole? Well, a half. So I'm going to multiply both the top and the bottom by x to the half. So by doing so, half plus a half is a whole. So I have 1 times x to the half, which is x to the half on top. I still have my cubed, and a half is a whole. So that gives me x to the half over x to the 4th, and I'd rewrite x to the half as the square root of x over x to the 4th. Cheesy biscuit from Red Lobster. Okay, so take this half through to both items. Okay. The square root of 100, you actually do know what that is, but we'll get back to that in a second. I can't have that half in the bottom, so what makes a whole? This half. That's why I'm choosing this half right here, because a half plus a half is a whole. So when I do this, I now have 100 to the half times x to the half over 1 whole x, and the square root of 100 is 10, so I actually have 10 root x over x as my final answer. I have to take that 4th root through to every single item in there. So what I did here was I rewrote all of that to the 1/4 power. And now I'm going to take that 1/4 through to everything. So 3 times a 4th is 3/4. 5 times a 4th is 5/4. 8 times a 4th is 8/4. This x is okay. It's okay because it's not negative. It's okay because it's not in the denominator. And it's okay because it's not improper. However, this is. So let's change this into a mixed number. So 4 goes into 5 one time with a remainder of 1/4. So that means I can split this y into y the 1st and y the 4th. This z, 8 over 4. Well, we can see how many times 4 goes into 8, but it just so happens we're lucky here because it's even. Z squared. So just like before, put all of your nice integers in the front. So we get a y and a z squared out in front. I have an x to the 3/4 and a y to the 1/4 in the back. Since they both have the same denominator, that means they have the same root. So I can pull out that 1/4 out of both of them and combine that into the 4th root. So I get yz squared, the 4th root of x cubed y. Because remember, whatever the denominator is the root, so that's why it's the 4th root. I have x cubed and a y the 1st power. Okay, a little more trickier with this problem. So what we're going to have to do is we're going to simplify. This is addition, which means you got to treat these 2 items as separate problems right now, and at the end see if we can put them together. If it was multiplication, I could just combine them all and go blazing through the problem, but I can't. So let's just take a look at the first one. The first one, I rewrote that as a third. So I'm going to take that third through to every single item. So 3/3, 1/3, z the third. This I can put that third through, put the third through, so it's 3/3, third through, and the third through. Okay. Now we got to see what simplifies. X to the 3/3. That simplifies to a whole. X. I have a y the 1/3 and z the 1/3. 8 to the 1/3. Alright, 8 to the 1/3. It's like saying, is there a number that's exactly the same 3 straight times that will give you 8? The answer is yes, there is. That number happens to be 2. 2 times 2 times 2 is 8. This is an x, and that is y the 1/3 and z the 1/3. So let's see what we notice here. Okay, I end up telling you that the final answer is 3x, y the 1/3, z the 1/3. And why? Well, here's why. This, treat all of this like your variable. Y to the 1/3, z to the 1/3. Okay, and look, it even has an x. It has an x, y to the 1/3, z to the 1/3. So does this. This has an x, y to the 1/3, z to the 1/3. So if there's one of all of this junk, and there's two of all of this junk, that means there's three of all that junk. That's why we can now combine it together, because there's one of it and two of it, which means there's three of it. And now I can rewrite those roots because it's 3 on the bottom. That means those both end up becoming the cubed root of what's underneath. And when we come back, we will discuss the chalupa in more detail.